TVE Happy Math Hour, a weekly interactive and reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it later if you need, and so others may have missed out on today's events will be able to come back and watch it. This session will be recorded. This event will be providing Tejano Passport points. The code will be posted on the chat at the end of the session for Tejano Passport points. So now, at this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with the information we'll be sharing today. Without further ado, I'm going to turn it over to our presenters today.
Hello, everyone. There is a link in the chat for 1324. So if you're taking 1324, then you want to press that link. If you're in 1314, then you would stay in this class. I want to wish everybody a happy Friday, happy Valentine's Day. And so today we're going to be covering problems that are from all of chapter 1, which is going to get you ready for exam 1, for your exam 1, which is coming up next week. And so here, let's go ahead and get started. So one of the first things that we saw in section 1.1 was to find the distance and midpoint between the points 8, 4, and 8 and -6. So the first thing you want to do is write down your distance formula. And I also like to identify my coordinates here as x1, y1, and x2, y2. And so we're going to plug these numbers into our formula. And so we would get 8 minus 8 squared plus -6 minus 4 squared. And if we simplify, 8 minus 8 is 0, and -6 minus 4 is -10. If we square those numbers, we get 0 plus 100, which would be 100. So we can take the square root of 100, and so that comes out as 10. So that would be your distance between those 2 points. And then the other thing that we want to find is the midpoint. So this is your midpoint formula. So we're still going to use the same points and plug them into our formula here. So we're going to end up with x1, which is 8, plus x2, which is 8, divided by 2, and -6 for y2 plus y1, which is 4, divided by 2. So if we simplify, we get 8 plus 8 is 16, divided by 2, and -6 plus 4 is -2. And we simplify some more. 16 divided by 2 is 8, and -2 divided by 2 is -1. So halfway between this point and this point, you would land on 8, -1. So these two were from section 1.1. Then we have write the standard form of the equation of a circle with the given characteristics. And so here they give us the center and the radius. Since they want us to write the standard form of the equation of the circle, I always like to start by writing that equation out. And so the standard form of a circle is x minus h squared plus y minus k squared is equal to r squared. In our center, the x coordinate, we call it h, and the y coordinate, we call it k, and then our radius is r equals 2. So what we're going to do is plug these numbers in to our standard form. So we end up with x minus h, which is -4, squared, plus y minus k, which is 2, squared is equal to our radius, which is 2, and we also square that. So then we can simplify a little bit, clean it up a little bit. So here we have negative, which would be positive, and then 2 squared is 4. And so this would be our standard form of our circle. Next, they want us to go reverse, right? They give us the equation, and they want us to find the center and the radius. So I always start by writing the standard form just so we can have it in front of us. And then I like writing our equation right below it. So here we have x is x. We have our subtraction sign. That means that h is going to be 1. And then over here we have the y's, but then we have a subtraction, and this one has addition. Okay, so we want to rewrite that a little bit so that we can have it in the standard form. So this addition, we can write it as negative or minus a negative 2, which is the same as positive 2. So that's going to tell me that k is going to be negative 2. And then our r squared is equal to 25. So from here, we can say that our center is going to be 1 and negative 2. And, you know, some people like to look at a shortcut here. If you have a minus 1, then you use the opposite, which is 1. If you have a positive 2, then we use the opposite of negative 2. And to solve for the radius, we said r squared equals to 25. In order to solve for r squared, I need to take the square root on both sides. So r is going to be 5. So that's our radius is 5. It says sketch the graph. So here I know that I'm working with the circle since our x is going to be squared and the y is also going to be squared. So the first thing you want to do is figure out what your center is. So our center is going to be h, which is 1, and k, which is going to be negative 2. And our radius was r squared equals 25, which in the previous slides we got 5. So to graph this, you want to find the center. However, on WebAssign, you don't want to plot it. If you plot it, it's going to count it wrong. Right now, I'm just putting a dot so we can see where we're at. So we have 1 and negative 2. And then the radius means that we're going to go from the center, we're going to go up 5, down 5, left 5, and right 5. So if I do that, then I end up with these points here. And we connect the points. And so that would be our circle. Again, make sure that you don't need this point here or the computer is going to count it incorrect. The next thing that we looked at is finding the intercepts and testing for symmetry. So first we'll work with the intercepts. So in order to solve for the x-intercept, we're always going to let y equals 0. So if I plug in y equals 0, then I get 0 is equal to negative 4x plus 1. And I need to solve for x. So I'm going to subtract 1 from both sides. And I end up with negative 1 equals to negative 4x. Divide by negative 4. And we get x is equal to 1/4. So that's going to be your x-intercept. For the y-intercept, you always let x equal 0 and solve for y. So for x, we're going to let it be 0. 0 times negative 4 is going to be 0. Plus 1, plus 1, we get y equals 1. So these are 2 points, and those are the x and y-intercept. And so if you were to graph this point and this point, then you would have this line. And just by looking at the line, we know that the graph has no symmetry. However, we are not always given the graph, so we can find the symmetry algebraically. So to do that, if you want to find the x-axis symmetry, then we're replacing our y with a negative y. And so we're going to go ahead and do that. So here's my equation. I'm going to replace y with a negative y. And then I need to solve for y. So if I divide by negative 1 on both sides, then I end up with y equals negative would be positive, and positive divided by negative would be negative. So if we compare our equation that we got here, is it the same as the original equation? So here we have y equals 4x minus 1. The original was negative 4x plus 1. They are not the same, therefore there's no symmetry for the x-axis. Now for the y-axis, it's similar, but now we're going to change x to a negative x. So if we plug it in, then we get y is equal to, that's our original equation. If I plug in a negative, then I get negative times negative, which will be positive. So we get 4x plus 1. If we compare a result with the original, they are not the same. So the answer here is there's no y symmetry. And then the last one, we're replacing x and y in the equation with negative. So this should be a negative here for the y. So we're going to replace our y with negative and the x with negative. And if we simplify, then we have negative, negative is positive. We're going to divide by that negative to clear the y. So we get y equals negative 4x minus 1. If we compare to the original, they're not the same. Therefore, there's no origin symmetry either. Okay, so you can look at the graph, or if you're not given the graph, then you can run this test. Okay, so the next question is determine whether the equation represents y as a function of x. So you can do this two different ways. You can look at the equation and think about what the graph looks like, or we can do it algebraically. The fastest way would be to look at what the graph looks like. And in 1.6, you were introduced to several different families. So this first equation, y equals x plus 4. If we visualize this, you want to ask yourself, is this a line, a circle, a parabola, a square root? What type of family is it, or which family does it belong to? And this one is going to be a line. Okay. So for a line, if we want to determine if it's a function, then we can use the vertical line test, which tells us that if we draw a vertical line and it touches the graph in one location only, then it's going to be a function. If we look at the second one, this is not a line anymore. Remember that a line, the highest exponent will be a 1. And here we have a 2, so it's no longer a line. But this one belongs to another family that we saw in 1.6. And so this family is the quadratic family, and the graph for those is a parabola. So if we were to graph it, it will look something like this, and this will also pass the vertical line test. So it's going to be a function. And then our third one, this is not a line, and it's not a parabola, but it also belongs to a family that we saw in 1.6, which is a square root family. And so if you try to think about what those graphs look like, it's going to look something like this. And this is also going to pass the vertical line test. Therefore, it is a function. And then lastly, whenever you have x squared and whenever you're also squaring the y, then that's going to be a circle. And the circle will fail the vertical line test. Therefore, it's not a function. Okay. So looking at the equations and what their graphs might be or what family they belong to can help us determine if it's a function. So the next one here, we have a cube. So this belongs to the cubic family. So the shape of that is going to be something like this. And that will also pass the vertical line test. So it's a function. And then the last one here, you might not recognize it because it wasn't part of the 1.6 family parent functions. So here, if we wanted to solve this, one, you could pick points and graph it. Or if we solve for y, I take the square root on both sides, and I get y is equal to the square root of x plus 4. We know how to graph that part, right? It's a square root that is shifted to the left. And then this one is a square root that is shifted to the left, but it's reflected on the x-axis. So the graph is going to look like this. Okay, so that's going to fail the vertical line test. But let's say that you didn't graph this. Then once you solve for y, you can pick any number you want for x. Let's say if I pick 0, then I get the square root of 4 is 2. But if I use 0 on the second equation, I get the square root of 4 is 2, but now I have that negative. So for my x value, I'm getting 2 separate answers. Therefore, it's going to be not a function. So if you personally have to take that square root, then it's not going to be a function. Okay, the next one is writing the equations for these graphs. And so first we want to recognize who does this graph belong to? What family does it belong to? So we can see that it's not a line, for example. It's not a parabola, but it does belong to the square root family. So what I can do is write my square root, and if it's helpful, you can sketch the parent function. And now we want to see how did this parent function, what do we need to do to it so that it lands on this graph over here? Well, we can see that the graph was shifted down, and then it was shifted to the left. Okay, so now we can start adding those numbers in there. So in order to go left, it went 2 units. So we're going to add a +2. That's going to make this graph go to the left. Then we need this red graph to go down. And so to represent the shift downward, we're subtracting 8 outside of the square root. And so now you can see that the original graph and this one after we added and subtracted 8 is the same. So your answer would be f of x equals square root of x plus 2 minus 8. Okay, let's try another one. So again, this one belongs to the square root family, which they kind of tell us here in the instructions. And so just to help us, I'm going to graph the parent function. And now we want to see what can we do to the square root of x so that it's going to fall in this location. So I can see that I moved to the right and I went down, but the graph was also reflected or inverted, right? So in order to bring it down here, I can put a negative square root of x, and that's going to cause it to open in this direction. Then what I can do is I can put a negative in the inside. So remember, if you have a negative on the outside of the function, it's going to reflect on your x-axis. If you have a negative inside, it's going to reflect on the y-axis. That's why this part of the graph, when reflected on the y-axis, will land on this side. Okay, so now we have this part of the graph, at least we have it pointing in the same direction. Now we just need to apply the shifts. Okay, so I needed to move to the right. So we're going to end up with x minus 2. That's going to cause it to move to the right. But notice that I went ahead and put my parentheses here. And then we're going to move it down. Okay, so if we move it down, then it's going to be minus 5. And there you go. So the next thing is graphing this type of function, which is called the piecewise function because it has 2 pieces. Okay, so there's many different ways to graph this, but one of the ways that that I like to do it is by focusing on the first equation. So, and then we focus on the second one. So the first one is 16 plus x. So I have it right here. And then it gives us conditions. So we're going to use the first equation if x is less than 0. So the values that I'm going to pick for x are going to be less than 0, -1, and -2. But I'm also going to include 0 because I want to include any number between 0 and -1. So there's like -0.5, for example. So here I'm going to have 0. If I plug in 0, then I get 16. The square root of 16 is 4. If I plug in a -1, then I get a square root of 15. And then we plug in -2, we get the square root of 14. Okay, so when we're going to graph this, the symbol here, the inequality, is a less than. It doesn't have the equal sign. So for x equals 0, we're going to want to make sure to have an open circle. And it's kind of hard to see here if it's open, but it looks like it's open. And you can zoom in if you, so it looks like I have it shaded. but hopefully on my last graph, it's going to be open. Okay, so once you plot those points, then we're going to focus on the second equation, 16 minus x. So I went ahead and added another point. Negative 16 plus 16 is 0, which is up here. Okay, but now let's do the second equation. Okay, so I guess I'm going to graph it first. So here's my graph. And notice that I do have my open circle. And I want to make sure that it's open because I don't have that equal sign. Okay, so that's the first equation. The second equation, we're going to pick values that are greater than or equal to 0. So I'm going to use 0, 1, 2, and we can use 16. And so if I plug in 0, I get 4. If I plug in 1, I get square root of 15. 2 gives me square root of 14. And 16 will give me 0. Now, since I have the equal sign here, then my point would be close. Okay. And so if I graph it, then we're going to have this picture here. So if we put the first picture and the second picture together, then our graph is going to look like this. Okay. And that closed dot is going to fall on that open one. So that's why it's going to look like it's close.
Bless you.
Thank you. Okay, so let me go ahead and do one more equation or one more example here. It says write the equations of the lines through the given point that is parallel and perpendicular to the given line. So here they give me this equation, and I'm trying to find another equation that's going to be parallel to this one. And so we want to identify that the lines would be parallel, which has a meaning for us, right? That means that the two lines will have the same slope. And so we need to find the slope for the first line so that we can find the slope of the second line. So to find the slope, I subtracted 8x on both sides, and I'm dividing by -2 on both sides. So -8 divided by -2 is 4, and 3 divided by -2 is -1/2. So for this line, all I care about is the slope, and that slope is 4. For a parallel line, I'm going to use the same slope. Okay, so now that I have my slope and I have a point, I can use the point slope formula here. Y minus y1 equals m times x minus x1. I'm going to plug in the information I have. And so that's going to give me y minus 1, that comes from the point. My slope, x minus 8, which is also from the point. We're going to distribute that 4, and we end up with 4x minus 32. I'm going to add the 1, and I get y equals 4x minus 31. So this line, if you graph it alongside this one, they're going to be parallel, which means they're never going to intersect. Now the second part of this is to find a line that's perpendicular. So the given line, the slope for that was 4, but since they want us to find the perpendicular, we're going to use the negative reciprocal, which means we're going to basically flip this number, which would be 1/4, and then take the negative of that, so -1/4, and then we do the same procedure, right? So we're going to plug in our information, and I get y minus 1 is equal to -1/4 x minus 8. Distribute that -1/4, so we get -1/4 x minus 8 times -1/4, and that comes out to -1/4 x plus 2. I'm going to add the 1, and we get y equals -1/4 x plus 3. Okay, so I'm going to let Mr. Carrizales continue with the rest of the slides.
Thank you so much, Ms. Chuka. All right, now let's consider the following. We have f of 1 is equal to 7 and f of 0 equals to 8. So they're asking us to write the linear function f that has the given conditions. or function values. So if recall, when evaluating functions, okay, this value here, 1, refers to our x value, okay, that we're putting into a function. And the output, or what comes out of this value, is a y value. So they're giving us basically 2 points. And when we have those 2 points, we can now write a linear function. So again, so what we need to do is we need to find the slope of the function, and then we also need to find at least one other point. And if we want to write it in a linear function, usually the other point we like to get is our y-intercept. So let's go ahead and get our slope. Like I said, they gave us 2 points. My input value 1 here is for x. My output value is y. So here's 1.17, and my other point is 0.8. So let's go ahead and get our slope. Our slope is given by this formula. Though given 2 points, it's y2 minus y1 divided by x2 minus x1. It doesn't matter which of these 2 points is a 0.1 or 0.2. But in this particular example, we're choosing 0.1 to be this 0.17 and 0.2 to be this one, 0.8. So if this is 0.1, this 1 refers to x1, this 7 refers to y1. And if this is 0.2, this point here refers to x2, and this is y2. So when I plug them in, we have 8 minus 7 divided by 0 minus 1. So 8 minus 7 is 1, 0 minus 1 is a negative 1. And the negative divided by a positive is a negative, and 1 divided by 1 is 1. Okay, so that is our slope. But with this information, it's going to be very easy to get the equation, because this other point here is they're giving me basically that y-intercept. They're saying that when x is equal to 0, just like Ms. Chuka showed us right now, we have our y value is 8. So this 8 is referring to our y-intercept. So with this information, I can write my equation, and I can use the equation of slope-intercept form, which is y equals mx plus b. And again, I replace the values that I know. M refers to my slope, that would be negative 1. B refers to my y-intercept, which would be a positive 8. And my answer would be here, y is equal to negative x plus 8. Now, I could have also, let's say that I had forgotten that this represents my y-intercept. I could have used the same equation that Ms. Chuka just used right now, which is a point slope formula, and I would have gotten my slope already and done the same process that she did with this previous example. I would have picked any of these 2 points. Let's say that they had not given me this one as the y-intercept, or I didn't know it was a y-intercept. I would have picked one of these 2 points, plugged it into this point slope formula, and I would have gotten the same answer. Okay, so this is one way to do the particular problem like this. So let's practice evaluating functions, or finding the value of functions if possible. Okay, so they give me this function, f of x is equal to 3x minus 8. So when they want me to evaluate the function at f of 1, again, what they're telling me is that I'm putting everywhere I see x, I'm going to plug in this 1, and I want to evaluate the function. Okay, so let's go ahead and do it. So here, again, everywhere I see x, I'll substitute that 1 into the function. So here we have f of 1 is equal to 3 times 1 minus 8. Let's go ahead and simplify. So we have 3 times 1 is 3, and 3 minus 8 is a negative 5. So again, the solution when f equals, for f of 1, our solution, or our output, is negative 5. Okay. Now let's look at the second example. They want us to evaluate f of x plus 4. Again, what this means is I'm going to substitute everywhere I see x, this input value, x plus 4. So let's go ahead and do it. So we have the function evaluated at x plus 4. This is my input value, and equals to 3 times x plus 4 minus 8. So we're going to simplify. The first simplifying is we need to distribute this 3 to the x, and we need to distribute it to the 4. So when we do that, 3 times x is 3x, 3 times 4 is 12, minus 8. Now we can combine like terms. We have 2 constant terms, a positive 12 and a negative 8. So 12 minus 8 is positive 4. So that would be our solution for that input value. Okay. So let's try one more. We have the function value. Evaluate the function value possible. They're giving us a function. G of t is equal to 5t squared minus 6t plus 4. And they want me to evaluate the function at g of 2. So what this means is everywhere I see t, I'm going to replace it with this 2 value. Okay. So I have I'm evaluating g of 2. So it equals 5 to the 2 squared minus 6 times 2 plus 4. Okay, let's simplify once again. 2 squared is 4. So the negative 6 times a positive 2 is a negative 12 plus 4. Let's go ahead and continue simplifying. The 5 times 4 is 20. And then we subtract 20 minus 12 is 8. And 8 plus 4 is 12. So again, the function evaluated at g of 2 is going to produce an output value of 12. Okay. All right, let's try one more with this input value. G evaluate at t minus 2. So again, everywhere I see t, I'm going to plug in this t minus 2. Okay. All right, so we have g of t minus 2 is equal to 5 times t minus 2 squared minus 6 times t minus 2 plus 4. Let's go ahead and simplify. This t minus 2 squared means that I have two of these guys. I have 2 minus 2, t minus 2. In order to simplify this part, I'm going to do FOIL. Okay, but before I do that, let me go ahead and simplify the remaining part. This negative 6 needs to be distributed to the t and to the negative 2. So the negative 6 times t is where I get this negative 6t. A negative with a negative is a positive, and 6 times 2 is 12. Okay, so then we have the plus 4. So now let's take care of business. Let's take care of this FOIL part here. Okay, so what I'm going to do is, again, FOIL means this first term has to be multiplied with this inner, with the outer, then this next term has to be multiplied with the first and then the last. Yes, so t times t is t squared. T times a minus 2 is a minus 2t. Now this term, minus 2 times t is a minus 2t. And the negative 2 times the negative 2 is this positive 4. Okay. Now let's combine like terms. When I combine like terms, I have a minus 2t and a minus 2t. That's going to give me this minus 4t right here. Okay. So let's continue simplifying. I need to distribute now this 5 to these three terms in here. So let's go ahead and do that. 5 times t squared is a 5t squared. 5 times a negative 4t is going to give me a negative 20t. And the 5 times 4 is 20. Okay, that allowed me to get rid of my parentheses because I distributed that 5. Now we have to combine like terms again. So I start with a 5t squared. There's no other 5t squared, so that is left alone. But I have a minus 20t and a minus 6t. These two are like terms. So minus 20t minus 6t is a minus 26t. And then I have three constants. I have a plus 20, plus 12, and a plus 4. So 20 plus 12 is the 32, plus 4 is the 36. So my final answer of inputting t minus 2 to my function is going to give me 5t squared minus 26t plus 36. Okay. All right. Now let's do basic operations with functions. In this one, what I want to do is I want to subtract function g of t minus g to the second. Yes? So again, it's basically a substitution game. Okay, so, and I like to do it in several parts. First, let me do the first one, g of t. Everywhere I see t, I'm going to plug in t. And again, they've already done that for us, so it's really nothing that I need to do. So I have 5t squared minus 6t plus 4. I have just the original function. Okay, but let's go ahead and evaluate g of 2 next, which is now in blue. Again, everywhere I see t, I'm going to plug in 2. And when I do that, I end up with 12. Okay, so now I'm going to subtract g of t minus this 12. So let me go ahead and put it together. I have the t was in red, so 5t squared minus 6t plus 4. That's what I got when I generated g of t, minus what I have for the value of g of 2, which was just 12. Okay, so a negative with a positive is a negative. And now I just need to combine like terms, and I just have two constants. I have the plus 4 and the minus 12. So plus 4 minus 12 is going to give me the negative 8. So the difference between these two functions is just 5t squared minus 6t minus 8. Okay. Now, what I just did was as like a preview of the basic operations with functions, but they give us a little bit of a different syntax. But if you do just the same thing that I just did before, these operations can be very, very simple. So let's take a look at what they're giving us. They're giving us two functions. I have this function in red, which is f of x, it's just the name, is x plus 2, and I have this function in blue, we call it g of x, and it's x minus 2. And if I want to do this first part, A, the way we read this is f plus g of x. And what they really want me to do for this A is just to do this. They want me to add function f with function g. This is the book representation of the addition of two functions. But if you look at it, what they really want me to do, again, it just becomes a substitution game. So let me replace f of x with the red one, x plus 2 plus g of x, which is my blue one, x minus 2, and I'm going to add these two. And to add these two, it basically, I'm just adding the like terms. I have x plus x, that's going to give me 2x, and the plus 2 minus 2 is 0. So here, f plus g of x, or the addition of function f with function g, is going to produce 2x. Okay? So very similarly, the second one, B, is a subtraction. But the way we read this is f minus g of x. Okay, so basically what they want me to do is just do this. Subtract function f of x with g of x. So again, my red one, which is the f of x, is x plus 2, minus my blue one, which is x minus 2. But because my g of x, this blue one, is a polynomial, I got to put a parentheses because then I have to distribute that negative symbol to two terms. So before I can simplify, or before I can do anything, I'm going to distribute that subtraction symbol or the negative symbol, however you want to look at it. So a negative with a positive is a negative, giving me the negative x. And the negative times the negative is a positive, give me the positive 2. Now I can combine my like terms. X minus x is 0, plus 2 is 4. So the subtraction of f minus g of x is 4. Okay. Now, if we look at C, we know that this is a multiplication symbol or procedure. When we have two things next to each other, we don't have to actually put a symbol in here. These two are being multiplied with each other, f and g. Okay, so again, if you follow my concept here, that f g of x is really saying I want to find what f of x times g of x is. So let me substitute. F of x, again, is my red one, x plus 2, times g of x, which is my blue one, x minus 2. Now this becomes FOIL. So x times x is x squared, x times a minus 2 is a minus 2x. Now the 2 times x is a plus 2x, and the 2 times a minus 2 is a negative 4. Let's go ahead and combine my like terms. So minus 2x plus 2x cancels, it's 0, leaving me with just x squared minus 4, and I can simplify that. That's just x squared 4. So then now the division, again, they're telling us that we want to evaluate f divided by g of x. So basically, they just want us to do that. Divide function f of x with g of x. Again, my red one is x plus 2. My g of x is the blue one, x minus 2. So since I cannot simplify this, these are this x plus 2 and this x minus 2 are together. They cannot be factored out or simplified. My answer just remains that way. X plus 2 over x minus 2. Okay. But again, on your homework and on your exam, you were asked to find the domain of this particular one. And the reason why they did that is because, again, this is one of our functions that can have a restriction on the domain, or that we cannot put any value for x to evaluate the function. So they'll ask us to find what is the domain of f divided by g of x. So again, to review that process, we never want the denominator to become 0, because if we do get 0 in the bottom of a fraction, we get something that's undefined. So let's see, is there an x value that we can put to this function that would give us an undefined? So to do that, algebraically, we can go ahead and set the denominator equal to 0. So we have x minus 2 is equal to 0. And when we solve for x, we find that if x is equal to 2, we would get 0 down here. And we can see it. 2 minus 2 is going to give us 0. So we cannot use 2 because it's a restriction. So when we write this in interval notation, we're going to write it like this. From negative infinity to 2, and it's a parentheses. The parentheses is telling me that I cannot use that value, but that's where I'm going to stop. Excuse me. And then we have this symbol here, which is called the union or the and. So these were all the negative numbers all the way up to 2 that I can use. Again, not including 2, but now we have the other half. So from positive 2, not including positive 2, all of the positive numbers all the way up to infinity that I can use to this function. Again, and this is my exception only, that too. Okay. All right. So let's go ahead and practice evaluating one more. Evaluate the function f of x is equal to x plus 3 with function g of x, which is x squared minus 2. And again, on this particular example, they want me to do the multiplication or the product of f and g. So this is what this means, or this is what it's saying, f g of x. So again, I like to rewrite it as this, f of x times g of x, because that's what they want me to do. So I'm just going to substitute. Again, my f of x is my red one, which is x plus 3. My g of x is my blue one, which is the x squared minus 2. And again, I'm going to do FOIL again. Okay, so we have x times x squared is the x cubed. X times the minus 2 is the minus 2x. Then we have the 3 times the x squared is the 3x squared. And the 3 times the negative 2 is the negative 6. Let's combine our like terms if we have any. So here I have a cube, there's no other cubes. Here I have a square, there's no other squares. Here I have a single x, there's no other x, and here's a constant. So there is no like terms to combine. Now, if you put this answer on the computer on your test, it's quite all right. It's not going to mark it wrong. But again, us mathematicians, we like to put it in standard form, and that's in descending order. Again, you don't have to do this, but our final answer would be x cubed plus 3x squared minus 2x minus 6 for the solution of f g of x. Okay. So let's go ahead and now move to a different topic. So we have a new symbol here. We have f with an open circle g. So this symbol means that we are now doing composite of functions. So here, this first one, a, they want us to find f composed of g. Okay, so the way I like to deal with composite functions is basically another substitution. The way I like to rewrite this f composed of g is by stating this. I want to evaluate a function f, but instead of putting a value in our expression here, I'm going to plug in another function. So to function f, I'm going to put function g. Okay, and if you do this, again, it becomes a substitution game again. So the first thing that I want to do is I'm evaluating the g of x. So here, this is what I'm putting into the function f. I'm putting in x minus 9. This is the function. Okay, so the function f belongs to this. So I'm going to write my function f, which is x plus 4. I'm evaluating this x minus 9 plus 4. So again, this is already simplified, so I can drop the parentheses and combine my like terms. So negative 9 plus 4 is going to give me a negative 5. So the composite of f composed of g is going to produce x minus 5. Okay, so now b, g composed of f. So this is it's just the opposite. Okay, the way I want to consider this, since g was first, to function g, I'm going to put in function f. Okay, so again, what I want to evaluate inside f of x is the x plus 4, which is in red. Let me rewrite this or plug in this value to my function. Everywhere I see x, I'm plugging in this x plus 4 to this blue one, right? So we have x plus 4 minus 9. This is already simplified. So I can drop the parentheses and combine my like terms. Plus 4 minus 9 is a minus 5. Now, a little piece of warning, okay? You'll never get this. If we flip these, it'll never be the same answer. It just happened to be this case on this particular problem. That was a simple problem, but this will hardly never happen, okay? F of G and G of F doesn't produce the same answers. Just a piece of information and warning, okay? All right, let's do this next one, which I get a lot of questions on this one. They want me to find the composite function of G composed of G. Well, this is nothing different. This is all they're asking me is that they want me to evaluate G with my input G. It's just putting in to function G itself. Okay, so again, function G is x minus 9. That's what I'm going to plug in to function G. So everywhere I see x, I'm going to plug in this x minus 9. So again, I have x minus 9 minus 9. This is already simplified, so I can drop the parentheses and combine my like terms. Minus 9 with a minus 9, it gives me a minus 18. So the composite of G composed of G produces x minus 18. Okay. All right, so let's go ahead and practice some more with these. Okay, I have two functions. F of x is equal to x squared. G of x is equal to x minus 1. The first one, again, they want me to find f composed of g. So I rewrite it as function f. I'm inputting function g. Function g is x minus 1. Everywhere I see x in function f, I'm going to plug it in. So we have x minus 1 squared. Do FOIL, and we get x squared minus 2x plus 1. Okay. The next one, g composed of f. Again, g came first, so to function g, I'm going to plug in f. So f x squared, everywhere I see x, to function g, I'm going to plug in this x squared. So we have x squared minus 1, and x squared is just x squared. So the final product is just x squared minus 1. Okay? And then the last one, g composed of g. So g is x minus 1. Everywhere I see x in the x minus 1, I'm going to plug it in. So we have x minus 1 minus 1. It's already simplified, so I can combine my like terms. Minus 1 is a minus 2. Okay. All right. So now we go into section 1.9. We're almost done. So they're asking us, does this graph have an inverse? So just to recall what Ms. Chuka covered, to find out if a graph is represented as a function means that every x value corresponds to only one value. And the way we did that visually or with a graph was with an imaginary vertical line test, right? Or I say it's a vertical line test, but I like to say that I have an imaginary line. And if my imaginary line crosses this graph once, then it's a function. Yes? So to show that if this graph has an inverse, we're going to do the opposite of that. And so opposite of a vertical line is a horizontal line, right? So again, what we want to test, if this is a inverse, that every y value corresponds to one x value. So again, so just like before, like a vertical line, we'll do a horizontal line test. We'll run imaginary vertical line, horizontal line, excuse me. And if this imaginary horizontal line crosses my graph only once, then it does have an inverse, okay? So let's look at this problem, determine whether the function has an inverse. And if it does, let's find the inverse. So I know by looking at it, okay, this is a line because it's in this form, mx plus b. So I know it's gonna pass my vertical line test. So again, one of the ways to help us is, again, knowing what this type of function is, right? And like I said, hopefully at this point, we recognize that it's a linear function and it will pass the vertical line test and it's going to pass the horizontal line test. Now, when this happens, when a function passes both the vertical and horizontal line tests, we say that this function is 1-to-1, hence it has an inverse, so hence we can find the inverse, okay? So let's go ahead and do it. So the steps to finding the inverse of a function are these. First, you're going to replace f of x with y. We're going to convert it back to an equation, okay? Because f of x replaced the variable y. So we have y is equal to 5x plus 4. The next thing we're going to do is we're going to interchange the x and y values. So again, the y's values are going to become x's and the x variables are going to become y's. So once I do this, I have this. X is equal to 5y plus 4. Then I'm going to solve for y. So what I'm going to do is I'm going to subtract 4 on both sides first. And I have x minus 4 is equal to 5y. Then I'm going to divide by 5 on both sides. And I'm going to have this x divided by 5 minus 4 over 5. Now, this is just the equation. Now, to indicate that what I just solved for is an inverse, now I'm going to replace y with this symbol, f to the exponent of negative 1. This symbol here means inverse. So replace the y with this symbol, f to the negative 1 of x is equal to 1/5 x minus 4/5. So this is the inverse function of this given function, f of x. Okay. So this is my last example. Again, for those of you who are doing face-to-face classes that are going to take your exam coming up, hopefully this review has helped. Again, if you're with us, if you want a copy of this presentation, on the top corner, on the where the block box is, where there's a little arrow with a box with an arrow pointing down, you can click on it and you can download our presentation. Okay. And again, if you did miss our presentation, they'll be uploaded later onto our EBCC YouTube channel. So again, thank you all. Have a happy Valentine's Day. Enjoy your all's weekend, but make sure you study. And I'll pass it now to our presenters.
Thank you, Mrs. Chuka, and thank you, Mr. Carrizales, for your wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on a YouTube playlist. Today's session will also be available on the playlist later today. Also linked is a short survey to help us improve our TVE sessions. Please take time to fill out the survey. We'll be back with Happy Math Hour next week, where Math 1314 will be covering the standard form of quadratic equations and graphing, and Math 1324 will be covering writing exponential equations into logarithmic form. Before you leave, I want to share the TVE sessions that we will have next. At 1 p.m. today, we will have the student success topic covering the Writing Center and CSD. Thank you all for coming in today. And like Mr. Carrizales said, happy Thanksgiving. Have a great weekend, and we hope that you'll have a lovely weekend. If you have any questions, feel free to use the chat box or mic. And have a great day, guys.